Cool.
Okay, so today we're going to be, let me share my screen. We're going to be discussing the idea of reading code. Um, before we can start to write code, we need to be able to read it. You know, if you think about it, before you could learn to write in school, you know, you needed to learn how to read. And so, and to become a better writer, you needed to read books by good writers so that you could see what good writing looked like. And so, with that in mind, there are various skills that we can learn to become a better reader. Now, I will say that I'm going to have to end things a little bit early today, but I've added some content to this so it will easily fill today and next week. So we'll we'll be we'll be just fine. Okay.
Okay, cool. Nice one.
So this is pretty much my guiding principle. You know, I heard a speaker uh, one time. He said that our lives change when our habits change, and so my goal here is to help you learn some new habits that can have a positive impact on your career. So, all that being said, 2004, Steve McConnell wrote this book, Code Complete. And he referenced a study from 1964 where they measured how programmers spent their time on a given work week. And among the various things that they did, they spent 14% of their time reading code and 13% of their time writing it. And he says in the book that he's seen nothing to indicate that those numbers have changed very much over the years. Now, 5 years later, Uncle Bob wrote Clean Code, and he claims there that developers spend 90% of their time reading code. He doesn't reference any studies, but he's a pretty smart guy. And, you know, I'll let him and Steve duke out over the detail. Now, in 2017, the IEEE published a study claiming that nearly 60% of a developer's time is spent trying to understand programs as opposed to creating them. So I'll call that reading versus writing. Regardless, but we're going to spend at least half of our time reading code during any given day. There's dozens of essential reference books that I could recommend for you to help you write better code. Can you think of even one that discusses how to read it? I'm going to mention.
Not really. Apart, I mean, I have read Clean Code, but I don't recall exactly if he mentions about how to actually read it.
Yeah.
More about
Well,
writing, I suppose.
I'm going to introduce you to a book that has some great ideas for how to read code better. So, I mean, if we spend half of our time reading code, we should learn how to do it well and improve our ability to do that. And so that's what we're on today. Okay. So think about some of the struggles that you have when you're reading code. So generally, what is it you're looking for when you're trying to read code? What are you trying to do? And what sorts of things make it difficult? And where do you tend to get stuck? These are
Do
all
you
the
want do you
things
want my
that,
input
well,
or?
sure, sure.
Yeah. Yeah, I think like when I'm reading code, it's just like, especially if I like haven't written any of it, like I'm just coming into a project, like maybe because one thing I'd like to be able to do eventually is maybe contribute more to open source. So like coming in to one of those sort of huge projects and being like, okay, like how does this actually work? Um, it can be quite like daunting, I think.
Yeah,
Um, Especially because they might be using like conventions that maybe you're not familiar with, and
right.
obviously, you know, it's a big code base. For example, Spring Boot would be one where I've sort of attempted to like get my head around it a bit. Because I use it day to day. So I was like, oh, maybe it'd be useful if, you know, I could contribute to that.
Yeah.
but I mean, there's a lot going on, and it's a bit like they use a lot of terminology that I'm not really like familiar with, like the naming conventions and stuff like that.
Right.
And yeah, I guess it would be really useful to know like how to like where do you actually start? Like what sort of layer do you start from? And like navigating like packages and stuff like that.
Yeah.
Um, yeah, it'd be good to sort of learn how to do that, I guess.
To learn, yes. So you have to know the fundamentals of the framework itself and the patterns and they call it the man, my brain's just not working today. But the,
Cool.
the patterns that you use and the naming conventions that you use in the language and that sort of thing.
Yeah.
So yeah, we will get to that. Okay, so before we get there though, let's consider some of the differences between reading a book for enjoyment and reading code. This is one of my favorite authors. Um, and I'm drawing a blank on his name. Hemingway, Ernest Hemingway.
Oh yeah.
so, basically, if you're going to read a book by Hemingway, you're going to be able to sit in a comfy chair and have a glass of wine and enjoy flipping through it. You might need you'll need to remember the characters and their various relationships and stuff. But unless you're reading a mystery novel or a technical document, you really don't have to pay particularly close attention to what you're reading. You can sort of, I don't know, I catch myself going over my eyes glazing over a page and I have no idea what I just read. And it's like, okay, do I go back and reread it or do I try and pick it up from the context what just happened?
That
Uh,
really resonates with me actually. That happens all the time.
yeah, yeah.
Is it
Um,
worth going back and reading it again or you know?
well, sometimes something
Yeah.
really key is happening there, and it's like, golly, why is everybody reacting so weird? Let me go back and reread this part. Oh yeah, look at that. So sometimes it really doesn't matter. But yeah, if you're reading code, you probably have to have a pen and paper handy or some way to take notes. I usually like to print it out and scribble on the paper and draw lines and connect things. You're going to use different tools and techniques. And frankly, reading code is hard work. Now writing is another thing. Both prose and code take a lot of planning and rework. In fact, Hemingway revised his original manuscripts over and over multiple times before he released them. And, you know, as the masterpieces they ended up being. And so I'll often tell people, some developers that I work with, you're not better than Hemingway. Okay, go back and rework this. Let's refactor that to be better because we can always make it better. So, so what makes code hard to read? We already talked about a couple of things. Um, these are some of the ideas that I've come up with. First, someone else wrote it. I wrote it, but I must have been drunk at the time. There's no
That's classic.
documentation to help it. People aren't following the coding standards. There's that one guy on the team who does it his own way. It's like, God, we have coding standards here. Uh, they include a bunch of magic numbers, or they'll reuse like a class variable as a local variable in a method, which is maddening. Uh, or they have these classes that just go on and on and on and on. Or maybe they'll use global variables, also known as singletons. Sorry, my dog is. Or just using bad names for things. A is not a useful variable name,
Yeah, definitely not.
and magical annotations, which is synonymous with Spring Boot, and
Yeah,
annotations
true.
every day. What is that called? What does it do? Oh gosh.
What do they
Um,
call that over name for it? Is it aspects oriented
well,
programming? Maybe, or-
they it uses aspect oriented programming where it goes back and sort of reprograms the code after it's been, well, I guess while it's being compiled, but yeah, after it inserts code in that you didn't write that
I see.
you wanted to. But yeah, that's that's effectively what annotations do is they go and squeeze code in there that does magic stuff for you that you didn't write. Um, so if you think about this, this looks like a list of code smells.
Yeah.
um, you know, the bottom line is that code is generally code that's hard to read is generally hard to maintain. Um, and so if it's hard to maintain, we have a better chance of introducing bugs. Uh, we we if we are working on existing code, we tend to follow the pattern that's already there. So if what they've done already is this mess, then we have a tendency to just copy that mess, paste it, and do a little modifications to it and spread that mess around. And then cleaning that up is going to be that much harder. We're not talking about refactoring right now. Be talking about that later, but for now, we're just going to focus on our ability to understand this code because most of the code, existing code that we see, is going to be hard to understand, but we want to be able to understand it so we can maintain it well. All right. So, what are some of the reasons we read code? We learn how it works. So, because we have to go fix something. What is it doing and why is it doing it that way? Or we're wanting to use this new library and want to make sure we understand how it works properly. Or maybe we're reading a book and we want to learn a new programming technique. And probably a lot of the time you're going to spend reading code is during a code review, making sure that the other guys are following the patterns. I support a 25-year-old Java desktop application that was written by a brilliant, prolific geophysicist. And he's taught himself how to program. And his favorite design pattern is copy paste. So it's there's a lot of duplicated code around there. Well, sort of duplicated code because he went back and fixed things here, but didn't fix them there. And so you change something in one place and it goes and explodes all over the place. I'm sure you've never seen that, but
No, no, not to that extent.
so and if there's a bug, I need to find it somewhere in the 750,000 lines of code that was written mostly by this one guy. It's pretty crazy.
Wow.
Um, so this is the book I want to introduce you to. Felienne Hermans has this book called The Programmer's Brain. And it gives us suggestions on how to understand how our brains work and to use that knowledge to increase how we work with it. Excuse me. So, oh, just a second.
That's all right. No, 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 no rush. I have actually heard of this book, but not read it
Sorry.
yet. So I've heard of it, but not read it. This book. It seemed really good from the blurb that I read.
I very highly recommend it. So,
Mm.
but I like to read books on optimizing how our brains work and stuff. So that's sort of my thing. But it's a gold mine for insights and suggestions, especially as a software developer. And so, and over here we have this map of how our brain works. I stole it from her book, so I'll give her full credit for the artwork. We're going to be referring to this a lot as well as her book. But essentially, what happens is when we're learning something, it's going to pass through our filter of our life experiences, our beliefs, our assumptions, and that sort of thing. And then it's going to be stored in our short-term memory, which is very small, basically between 5 and 9 items at a time. And then it's going to move to our working memory, um, where we'll do whatever processing needs to happen. And then if it's something we need to remember long term, we'll move it into our long term memory, associate it with something that's already in our long term memory. Okay. So there's 3 different ways that code can be hard to read. So first, it might have an unfamiliar syntax, so you may not understand it. Here, it's quite literally all Greek to me.
Yeah, I was going to say it looks like hieroglyphics or
Yeah,
something.
this is APL. It's a programming language that I learned in college. This was our entry level programming language that we learned in college. It's crazy.
It looks nuts.
Yeah, but yeah, if you, probably about the only thing you can figure out is that this is a comment, and
Yeah.
otherwise it's craziness. So yeah, if you don't know how to read that, then you'll never be able to figure it out. Maybe you're not familiar with a specific syntax. So you have a good idea what it's trying to do, but you don't know exactly how it's going about it. I mean, even after a decade, a lot of people are still confused by lambda expressions in Java and how does that work and what does it mean. So
Mhm.
if you're not familiar with it, then if you come across it, you're going to get confused. And finally, there's code that has a sophisticated algorithm that is just hard to follow, or we say it has a high cognitive complexity. You just can't keep all of these variables in your mind at the same time. So what do we do? All right, let's look at our diagram of our brain, and we use this as a map for how we can overcome these 3 types of confusion. So you think of your long-term memory as like a hard disk, and your short-term memory as your RAM, and your working memory as a CPU. So if we use a computer model of our brain, um, and when you're running a program in your head, these cognitive scientists call that tracing, which, as I recall, that's what we used to call debugging back in the day when I was first programming. So, how does our brain work when we do this? First, we're going to read the code into our short-term memory. Now, consider your short-term memory lasts about 30 seconds on the outside. You may have heard of Miller's magic number, that we can remember 5 plus or minus 2 things at a time. That's why phone numbers are divided up into groups of 2 and 3. Or in the US, we've got a social security number, and that's divided up into 3 numbers, then 2 numbers, and 4 numbers, because it's easier for us to remember 3 groups of 3 or 4 than it is to remember 13 numbers. So, and recent studies actually show that, with the advent of cell phones and social media and scrolling all day, that our our short-term memory is actually even shorter. That's numbers closer to 4 plus or minus 2. So, so how can we improve our efficiency using our short-term memory? Okay, we're going to have a quick exercise.
Okay.
I'm going to show you some characters, and I want to just show them real quickly. I want to see if you can remember them. All right, ready?
Yeah.
Okay. So that was probably hard to remember, right? Unless you're Russian, and even then, it's just jumbled nonsense. Um, so why do we have trouble remembering that? We've overloaded our short-term memory, and we can't really do anything with it. We don't have any way to associate it with anything we know already. Okay, so let's try something different. Okay, now that was almost impossible, um, In fact, if you tried to write those letters down, you'd be surprised. You likely would remember more than you thought you would. But why is this easier? Well, we have some association with something we already know. We're able to recognize the symbols because they've been already stored in our long-term memory. So hold that thought. We're going to do this one more time. Okay. Now, that one was easy to remember,
Yeah.
right? Why is that? We can associate the letters with something in our long-term memory, and we can have those combinations of letters, and even that whole phrase is stored in our long-term memory. And so we make an instant association. And so basically that grouping of things together into familiar patterns is called chunking. And so if we can use chunking, we can remember things better. Now,
Okay.
I mentioned how if you tried to write down those random letters, you probably remember more of them than you thought. There's this concept called iconic memory, um, you know, where it's sort of like a persistence of vision when when you see light pass in front of you and it looks like a line. So when we read some code, it goes through a filter, and that represents whatever personal filter you may put on it. Like your personal experiences, your beliefs, your health, whatever's going on in your life. Then before it gets to short-term memory, it passes through something called sensory memory. And you can think of that as sort of an I/O bus. So when you see something quickly, like we did, you have a sort of mental picture of it that's stored in a special short-term memory called iconic memory. And from here, you can make very quick associations with your long-term memory. So how do we use this? Well, if you're an experienced developer, what's the first thing you do when you're looking at some unfamiliar code? So here's some code. The first thing you'll probably do is you're likely going to glance at the shape of the code. It gives you some idea of the structure and design of the code. This little section to the right is an IntelliJ plugin called Code Glance Pro, and I use it to help me dig through code that I'm unfamiliar with. You can quickly see that, okay, this is a bunch of if statements, and here's another bunch of if statements. And these two groups of if statements, those seem to be similar. So that's probably copied code or it's calling the same thing. I don't know, but just based on my experience, that's what I can tell.
Mhm.
So yeah,
What was that
this
plugin called? Sorry. Oh, Code Glance.
Code
Cool.
Glance Pro. Okay, and it displays a mini map on the side. If you use Eclipse or VS Code, it's a configuration setting, but for JetBrains, you have to install the plugin. And I highly recommend it. I use it all the time.
Cool. I'll check that out.
Okay. All right. So back to our brain model. So we can increase the effectiveness of our short-term memory by using chunking. All right. So what are some ways we can chunk the code that we read so that we can understand it more quickly? So I've given you one simple tool. You can try to recognize the shape of the code layout to determine the structure and possible flow. What are some other things that we might do?
Um,
Design patterns.
yeah.
they're,
Cool.
they're an excellent way to you attach a large set of information to a single idea or phrase or something like that. Like this is the publisher subscriber or observer design pattern. If you know how it's implemented, then you know how to recognize it when you see it in the code, right? So design patterns are a great way to communicate complex ideas very quickly, and that's a useful skill. Now, I used to race sailboats, and when the pilot would shout out, "Trim the jib sail," trim the jib sheet, that was much more succinct and useful than saying, jump up on the front of the boat and grab the small sail, the rope for the small sail, pull it in a little tighter so that it's parallel with the mainsail, and then tie it off, and then get back on the side of the boat so that we don't fall over.
I mean, yeah, that's a bit more succinct, isn't it?
Absolutely. And this is why we use jargon in, well, basically in any industry. But design patterns is a great way for us to succinctly describe a more complex concept. Another thing that we can use is documentation in the comments. Um, they can be very helpful. And, it's interesting. Studies show that developers who are less experienced depend more on comments than people who are more experienced. Wonder why that would be. Once bitten, twice shy. We can have comments that explain why something does what it does. This is why this particular value is here. Or we can have section comments like this. It sets off a section of code to describe what it's doing. I generally recommend that people will take this sort of thing and turn it into an appropriately named method. But the comments can be helpful in finding that sort of thing. All of these kind of comments are called beacons because they help whoever's reading the code find their way through the code, similar to how a lighthouse will help sailors to find their way on the sea. Lots of sailing metaphors today. But,
Great. Love it.
simple beacons represent, something called a simple beacon represents a single concept, and compound beacons represent multiple concepts. So, like, this would be a simple beacon, and this would be a uh, compound beacon. So, why does that matter? Well, when you write your code, you need to leave beacons for that next developer who's going to be coming along, which may well be you in a week or two. Okay, so with all this in mind, how do we use what we know to address the different kinds of confusion we will run into? Right? First, we've got this, we don't, lack of knowledge. We don't understand anything about the code. Well, how do we overcome that? We learn, we research, we study, learn the syntax of language, that syntax to your long-term memory so that you can be able to start understanding how this code works next time you see it. So I can tell you that the way APL works is it goes one character at a time from right to left on each line and operates. So this is a function name, and this is a parameter. And so whatever parameters you pass, it's going to use. So this would be 1, 2, 3, 4 different parameters. It's going to DET, so it finds the determinant of those things passed in, and and then IO, whatever that rectangle IO is. IO, it's getting input from the user. This is assigning a value. So this left arrow is assigning a value there. This iota is generating a list of numbers, and this is called the ceiling. So it'll find the maximum, and then that's the division, and then this is an OR bar. So it's evaluating a determinant. Okay. And it's a very concise way to do that. I'm sure doing it in Java or JavaScript would be much more complex. So anyway,
It kind of looks, it just looks complex, I guess, because I don't know what's going on. But
right,
maybe once you get the
right.
syntax, it probably makes
But
more sense.
but now, I've given you a little bit of background on how APL works. It has been 20 some odd years since I've worked in, okay, 35 years. So,
Does anyone still use it?
oh yeah, oh yeah. There are crazy people still writing in COBOL and Fortran and APL, all kinds of
Yeah,
crazy languages. So yeah.
nice.
Okay, so our second confusion. I don't understand the syntax, so how do we read that more quickly? Well, similar to not understanding the language at all, we need to become familiar with uh, code structures that or idioms that we're not familiar with, and we need to practice them and study them and learn them. And if you still have trouble, find books that help you to understand them better. There are ways to get this kind of information and to make it second nature. Um, and then finally, we've got lack of processing power. So you got something that has a sophisticated algorithm. It's hard to follow. It's high cognitive complexity. Um, how are we going to read this code more quickly? Well, this is where you're going to need an external brain extension. You, know, you need to print it out and step through it, keeping track of the variables and the calculations, or you can use a debugger to walk through it. That will make it easier. Um, we're going to talk later about other ways to get better at doing this. Okay, so we're going to do a quick exercise. It's just to practice noticing beacons in code. I want to show you a small snippet of code, look over it for a minute or so, and just make a note of the beacons that you see and why you consider them to be beacons. So
Okay.
the more we practice something, the better we are able to recognize it. So
So the Java docs are standing out to me
mhm,
on the first glance. They're
if
always so useful, actually.
right.
Whenever I see Java without Java docs, it's like, why?
Well, really only makes sense if it's public. But
Yeah.
yeah.
Um, what else?
So we're missing one parameter.
I mean, removal reasons is quite a good variable
Mhm.
name, I guess.
Yeah, that's
Sort of
good.
helps you make sense of the function.
Hmm. And
Oh yeah, and that comment there, of course.
yeah, also, the curly braces help to set things off, and the
Oh
lining up of the parameters helps it to make things a little bit easier to read,
yeah.
lining things up. Um,
It's like I find it's like slightly, I don't know if this is a personal preference, but like the if statements are quite like sort of bunched together.
mhm,
Um, and personally, find that like more difficult to read.
right,
So like when I'm writing, I'll like add a little bit of white space here and there just to sort of
right. Have this as a separate else, and then in, an if statement within the else clause, rather than just an else if.
maybe even just like at the end of the first if block, just a bit of white space just to sort of
Oh, I see.
visually sort of separate it.
Right.
I don't know if that's like good
Mhm.
practice or just like a personal sort of preference or
Well, if it
thing.
makes the code easier to read, it's a good practice.
Yeah.
Um, and there are constants in here. This this R string toolbox removal title. That's
Yeah, I feel like that's not a very
it's not
clear
well
what's going on there.
named,
No.
but at least they're using constants. If you actually go in and looking at the source code for this points to XML constants for supporting multiple languages.
Mhm.
So
Is this
um,
actually from Reddit or is this something else?
this is some code I will show you later. It's from a project that's no longer supported. It's the ugliest code I've ever been able to find on GitHub. And it's an Android project for reading Reddit.
Oh,
And it's called Slide. And yeah, it's pretty crazy stuff.
okay.
Yeah, thing is a bad name, but
Yeah,
these
that's
other
really bad.
variables are actually fairly well done. The builder, the context for reasons. Yeah. So anyhow, all these beacons, they make the code a little bit easier to navigate, and you want to make it a point to leave beacons in your code. As you get experience reading code, you're going to notice things that are beacons, and your eye will be drawn to them so that it makes the code easier to read. Okay, so first two ways of getting confused are remedied by learning stuff and remembering it. How do we make that remembering thing easier? Do we really need to remember stuff? I mean, what's wrong with Google? Isn't Google supposed to keep us from having to remember everything? Not
Yeah, I
exactly,
mean, that's the default that people do nowadays, isn't it? It's like, oh, Google it.
right? If you think about it, the more you know, the faster it is to learn new stuff because you're able to make more associations in your long-term memory. And then you don't have to look it up, which breaks your flow. And I don't know, well, studies say when you get distracted, it takes on average 15 minutes to get back to where you were. But half the time when I get distracted and look something up on Google, there's an interesting little link there to the side, or if I'm on what is it, Stack Exchange or Stack Overflow, they've got that
Mm.
little list to the side. It's like, oh yeah, I always did wonder about that question in Lord of the Rings, and that's perfectly relevant to what I'm researching right now. I wonder what the answer to that. So, yeah,
Yeah, the
I'm
rabbit
sure that
hole
never happens to you, but it does happen to me on occasion. So
definitely happens to me, I have to say.
yes. So there is this concept called the memory rate of decay. So the way our brains usually remember things is through repetition. Of course, there's also noteworthy events like surprises or crises or that sort of thing. But we're not going to worry about that right now. Generally, programming doesn't include many of those, if you're lucky. Um, but we need to spread out the learning, so we don't try to cram, which is just the opposite of how our schools work, if you think about it. But there's a rate of decay for how we remember things. So if you continue to review the material every couple of days for a few weeks, you could remember it more or less indefinitely. And this is called spaced repetition. Your optimal times to go and review something is 1 day, and then 3 days, and then 6 days, and then 10 days. There is actually a really cool site. I got this information from a really clever site. It goes into some depth about how our memory works, and it's exceptionally well done. If you have 20 minutes or so to dig into it, this is the website. That's what their homepage looks like. So if
Cool,
you,
I'll have a look.
yeah, it's it's very interesting, and it's a great way to start wasting 20 minutes and end up wasting a couple of hours because lots of interesting stuff there.
But it's a
Um,
useful skill that will stay for life, you know?
Absolutely. Now there are flashcard apps, and most of these will run on your phone as well, and they help you with specific um, time of recall. Clearly, I'm not getting this morning. The reinforcement pattern, and you can use them to learn just about anything. Lots of developers are trying to learn lots of things. So chances are good that if you're trying to learn some new concept, there's already a card deck out there that you can use to help remember it. And as you practice some of the exercises we went through earlier, you're going to notice things that you don't understand, but you should. And you're going to, that'll give you an idea of what to stick into your little memory app here. So, one important tip for remembering things is we remember things better by practicing remembering. Okay, so you'll want to read the prompt on the flashcard and then try to remember before you flip the flashcard over.
Okay.
Okay, so there's two things we want to strengthen our memory. There's two things we want to do. Okay, we want to remember our stored strength, which is that things in our memory tend to stay there, and our retrieval strength, which is our ability to recall what we've already stored. So for storage strength, you just need to do the repetition a few times and it'll be there. You've probably been in a situation where you couldn't remember like your phone number or the phone number of someone that you did know the number for. You just can't recall it. So we have the storage strength just fine. It's the recall that we have trouble with. So you need to practice remembering. Okay. So when you're when you're trying to remember something, sure, go ahead and Google it. But before you click enter, think about it for a second and try to remember. And you'll get better at remembering. You'll increase your recall. Okay. I'll cover one more topic and then I'm going to have to call it quits here. So,
Okay.
one other thing to consider is we don't necessarily remember things exactly as they were. Our memories are often colored by our experiences, our personal or maybe our cultural filters. Details could be changed or forgotten. And this is called elaboration. So, well, actually, elaboration is it's the idea of thinking about what you want to remember. Okay. And it's an exercise in relating existing memories to a new memory so that you can make sure that you remember it properly. Does that make sense?
Yeah. Yeah. Yeah.
Okay. So first, we'll consider you want a new concept that you want to learn. You want to understand the pattern matching functionality in Java or the comprehensions. This is called a comprehension in Python. You want to make sure you remember it correctly because syntax errors slow you down and they make you go to Google and then you go find yourself looking up Lord of the Rings. And so this is an exercise to help you remember a new programming concept. So what are the similarities? What other similar concept does this make you think of? And you can write down those related concepts. All right. Then for each of these related concepts, you can say, okay, so why does that new concept make me think of this? Does it share syntax? Is it similar context? Is it similar to a concept, an alternative way of doing things that I already know how to do it? Okay. And then what alternatives are there? What other ways do I know to write code that can achieve this same thing? And try to create a couple of variants of doing that. Do other programming languages have a similar concept? Maybe I can, and writing down this helps a lot. How do these other programming languages do it, and how are they similar and how are they different? Does this concept fit into a particular paradigm or domain or framework? Okay. So, um, all right. I'm gonna have to just leave it here.
Okay.
Yeah, I think this will
Um,
be a good place to jump back in. But
okay, cool.
but but what at least what I've given you is a couple of tools and a couple of exercises to improve your memory, and at least one site to go and dig into. To she's got some skills for how to improve your memory and and how to use some of these tools.
Cool.
And
Yeah, that's great. I mean, yeah, I can check them out this afternoon. I think I've got some
okay,
time, so
very good. And so yeah, next week we will go further into detail and talk about how we can apply a lot of these things uh, in better ways.
cool. Sounds
Okay,
good. All right.
so, so I hope you found that helpful. And
Yeah, it's really good. I think yeah, that this sort of like all this memory and like cognitive stuff, I think is really important. And people don't
absolutely,
really, a lot of people don't really think about it. So I
yeah,
think, yeah, this has all been really helpful. Um,
excellent.
cool.
And I will see you here next week, same
Yep.
time, same bat channel.
Sweet. All right. Nice one, Scott. Thank you so much.
All right,
Have
you
a
have a
good
great
week.
day. All right,
Bye.
bye.